Hello students, in previous video we have seen Hess law of constant heat summation, its statement, explanation, illustration with suitable example and application. And also we have seen one problem on Hess law. It is present on the blackboard. First problem, calculate delta H naught for the given reaction. 2H3 BO4 aqueous to give B2O3 solid plus 3H2. We have to calculate standard enthalpy change of this reaction using or from the given thermochemical equations. And to obtain this equation, given equation, some modifications are made in case of these three thermochemical equations. First of all, we have to multiply equation first by 2. Divide equation B by 2, reverse equation C and divide it after reversing by 2 and finally add all the modified equations, and these modifications are made here. This is first equation, second, third, and if these modified equations are added, we get this equation, and whatever changes are made on thermochemical equation, same changes are made on enthalpy changes of these thermochemical equations, and finally by adding all these enthalpy changes along with their signs, we get enthalpy change of the given reaction. In this case, enthalpy change of the reaction is plus 14.4 kilojoule. In this way, we have seen first problem. Now we discuss about second problem. What is second problem? Calculate delta H naught, standard enthalpy change of following reaction. At 298 Kelvin. Reaction is given H2 B4 O7 solid plus H2O liquid to give 4 HbO2 aqueous from the given data. First example, thermochemical equation is given 2H3 BO3 aqueous gives B2O3 solid plus 3H2O liquid, and enthalpy change of this reaction is given delta H naught 14.4 kilojoule per mole. Second, S3 BO3 aqueous gives HbO2 aqueous plus H2O liquid, and enthalpy change of this reaction is minus 0.02 kilojoule per mole. And third reaction is given H2B4 O7 solid to give 2 B2O3 solid plus H2O liquid, and enthalpy change of this reaction delta H naught is 17.3 kilojoule per mole. Now here this is given required equation. How this problem is solved? Required equation. What is that? H2 B4O7 solid plus H2O liquid to give 4HbO2 solid plus 3H2 liquid, and we have to calculate enthalpy change of this reaction. Now to obtain this given equation from given thermochemical equations, we have to modify these equations. Modifications. What are the modifications? Now here, by seeing this equation, you can modify the following thermochemical equations. Here we have 4HbO2 in equation 2. 4HbO2 aqueous is present in the given equation 4 moles, but in second equation only 1 mole is there. That means you can multiply equation 2 by 4. Now first equation, here we have to reverse this equation and it is to be multiplied by 2. That means modifications. Multiply equation 1 by 2 and reverse it. Second, multiply equation 2 by 4. Third, keep equation 3 as it is. Equation 3 is to be kept as it is because one more of H2 B4O7 is present on reactant side in the given equation, and same thing is present in third equation, therefore it is to be kept as it is. Now modifications, modified equations. First of all, you have to multiply this equation. First of all, you reverse it. You can reverse this equation as B2O3 solid plus 3H2O liquid to give 2H3BO3. 2H3BO3 aqueous. Now this is only reverse. After that you have to multiply this reverse equation by 2. That means you will get 2H2BO3 plus 6H2O liquid to give 4H3BO3. Now if you multiply this equation by 2, you have to multiply its enthalpy also by 2. On multiplication you get delta H naught. Now on reversing the equation, sign of the enthalpy of first equation becomes negative. And after that, if this negative value is multiplied by 2, you will get minus 28.8 kilojoule. Now, in case of second, you have to multiply second equation by 4. That means 4H3BO3. 4H3BO3 aqueous plus it gives 4HbO2 aqueous plus 4H2O liquid. This is modified second equation. And enthalpy change. Again here we have to multiply this value by 4. That means on multiplication you get minus 0.08 kilojoule. And third equation is to be kept as it is. H2B4O7 solid gives 2B2O3 solid plus H2O liquid. And enthalpy change is as it is. It is 17.3 kilojoule. In this way, we have modified all these three thermochemical equations as per requirement. And final procedure is what? Here you can write code. Add all the modified equations. Add all the modified equations. After modification, see what happens. 2B2O3 cancels with 2B2O3. 4H3BO3 cancels with 4H3BO3. In this way, we have cancelled some species, and what is left behind? H2B4O7 solid plus, now here there are 6 H2O and 3 H2O. Here 4 plus 1, 5. That means here 1 H2O remains on reactant side. 6 minus 5 means here 1 water molecule remains behind, and it gives 4HbO2 aqueous. And enthalpy change of this reaction is obtained by adding all these values. It comes minus 11.58 kilojoule. This is delta H naught of given reaction. Here negative sign, this value is bigger than the addition of these 2, and therefore minus 11.58 kilojoule is the answer of this problem. Now next problem we have to discuss about third problem. What is third problem? Calculate the standard enthalpy change standard enthalpy of formation of methanol from the following data. From the following data. Some thermochemical equations are given. First, CH3OH liquid plus 3/2 O2 gas to give CO2 gas plus 2H2O liquid. And enthalpy of combustion of this reaction is minus 726 kilojoule per mole. Second thermochemical equation is given. Carbon, graphite plus O2 gas to give CO2 gas. And enthalpy of combustion of carbon is given. It is minus 393 kilojoule per mole. And last thermochemical equation, H2 gas plus 1/2 O2 gas to give H2O liquid. And enthalpy change of this reaction, enthalpy of formation of water is minus 286 kilojoule per mole. From this data you can calculate enthalpy of formation of methanol. Here, as per the definition of enthalpy of formation, it is enthalpy change when 1 mole of the substance in its standard physical state is formed from its constituent elements. Here we have to write formation equation for methanol. 1 mole of methanol is formed. 1 mole. The substance to be formed is written. It's 1 mole on product side. And constituent elements can be known from the molecular formula of the substance itself. There are carbon, hydrogen and oxygen constituent elements. Carbon, graphite, plus 2H2 gas plus 1/2 O2 gas. This is formation equation for methanol. Here, first of all, 1 mole of methanol is written on product side. From the formula, constituent elements are written on reactant side. First of all, rough equation is written, and then by seeing constituent elements, it is to be balanced. Here in methanol molecule, 1 carbon is there, therefore it is 1 carbon. There are 4 hydrogen atoms, H3 plus 1, that means 4 hydrogen atoms, that means 2 hydrogen molecules, and only 1 oxygen atom is half molecule. In this way, this equation is to be balanced, and we have to calculate enthalpy of this, enthalpy of formation of methanol. Delta H not F. Now, how this problem is solved? First of all, what are the modifications? Here you can write modifications. Modifications. Now see, here 1 mole of methanol is present on product side. We require it on product side. But in first equation 1 mole of methanol is given. But it is on reactant side. Therefore, first equation is to be reversed. Reverse equation 1. This is first modification. Now, equation 2. Here, carbon, 1 mole of carbon graphite is required. And it is present on reactant side itself. Therefore, keep equation 2 as it is. Third modification. Now here, hydrogen. We require 2 moles of hydrogen gas on reactant side. In third equation, it is present on reactant side, but only 1 mole is present. Therefore, we have to multiply equation 3. Multiply equation 3 by 2. And finally, add all the modified equations. Now modified equations. First, reverse equation 1, that means products are written as reactants. To give CH3OH liquid plus 1/2 plus 3 by 2 O2. 3 by 2 O2 gas. If this equation is reversed, its enthalpy also reverses, it becomes positive. That means enthalpy of this reaction becomes plus 726 kilojoule. Now, second equation, we have to keep it as it is. That means carbon graphite plus O2 gas to give CO2 gas. And enthalpy of this reaction is to be kept as it is. It is minus 393 kilojoule. And third equation. Here we have to multiply equation 3 by 2. That means on multiplication it becomes 2H2 gas plus 3 by 2. 2 into 1 by 2 means it becomes 1 O2 gas and it gives 2H2O liquid. Enthalpy of this reaction is also multiplied by 2. It becomes, that means minus 286 into 2. That means it becomes minus 572 kilojoule. And finally, we have to add all these modified equations. Then we get, now see here, what is cancelled? CO2 is cancelled. Then 2H2O gets cancelled. What is left? Now here, you see, O2 plus O2, 2O2. Now, from 2O2, 3 by 2O2 is minus. It becomes 1 by 2 O2. Here you write H2 is to be kept. Here carbon graphite plus 2H2 gas plus 1 half O2 gas to give CH3OH liquid. This is the required equation. Now here you can see 2 minus 3 by 2 means what? 4 minus 3 by 2, that means 1 by 2. In this way we get 1 by 2 O2 on reactant side. Required equation is obtained and we have to obtain enthalpy of formation of methanol. By adding all these terms, on addition it becomes minus 239 kilojoule per mole. You can do the additions. Now minus 393 plus minus addition of these two, and from this value we have to, this is bigger addition. From this value we have to subtract 273. You will get minus 239 kilojoule per mole. This is the answer. Enthalpy of formation of methanol. Now we see fourth problem. What is fourth problem? Calculate the standard enthalpy of formation of ethane from the following data. There are three thermochemical equations given. First, C2H6 gas plus 7 by 2 O2 gas to give 2 CO2 gas plus 3 H2O liquid. And enthalpy of this reaction is given minus 1560 kilojoule. Second equation is given H2 gas plus 1 half O2 gas to give H2O liquid, and enthalpy of this reaction is given minus 285.8 kilojoule. Third equation is given carbon graphite plus O2 gas to give CO2 gas, and enthalpy change of this reaction is given, it is minus 393.5 kilojoule. Now from this data you have to calculate enthalpy of formation of ethane. Now required equation, formation equation. Now ethane means C2H6 gas. 1 mole of ethane is written on product side, and constituent elements are carbon and hydrogen. Here 2 carbon graphite plus 6 hydrogen means 3 H2 molecules. This is simple formation equation of ethane, and we have to calculate enthalpy, standard enthalpy of formation of this reaction. Now, what modifications are done? Now, by seeing this equation, you can modify the given thermochemical equations. Here, in first equation, C2H6, 1 mole of ethane is present on reactant side. It must be on product side. Therefore, you have to reverse equation 1. First, reverse equation 1. Second equation, we want 3 hydrogen molecules on reactant side. In equation, only 1 mole of hydrogen is present on reactant side. Therefore, you have to multiply equation 2 by 3. Then, third, here we want carbon 2 moles on reactant side. Only 1 mole is present. Therefore, multiply equation 3 by 2 and final add all the modified equations. Now, modified equations. First, we have to reverse equation 1. 2 CO2 gas plus 3 H2O liquid to give C2H6 gas plus 3 by 2, not 3 by 2, 7 by 2 O2 gas, and if equation is reversed, sign of the enthalpy becomes positive, plus 1560 kilojoule. Now second, multiply equation 2 by 3. That means we have to obtain 3H2 gas plus 3 by 2 O2 gas to give 3H2O liquid. And enthalpy change is again multiplied by 3. Minus 286.5 into 3. It becomes minus 857.4 kilojoule. Third equation, 3 is multiplied by 2. That means it becomes carbon, 2 carbon graphite plus 2 O2 gas to give 2 CO2 gas. And if this enthalpy is multiplied by 2, it becomes minus 787 kilojoule. All modifications are made. And finally, we have to add all these 3 equations. 2 CO2 gets cancelled, 3 H2O gets cancelled. What is left behind? Now here, 7 by 2 O2 on product side, 3 by 2 plus 2 by 2, it becomes 7 by 2. That means here we, now here see, 3 by 2 plus 3 by 2, it becomes 4 plus 3 by 2, that means 7 by 2, it gets cancelled with this. What is left behind? 2 carbon graphite plus 2 H2O, 2 H2 gas to give, not 3 H2 gas. 2 carbon graphite plus 3 H2 gas to give C2H6 gas. Here, this is cancelled. We write this final equation as per requirement, and we have to calculate enthalpy of formation by adding these enthalpies. If you add these enthalpies, we get answer minus 84.4 kilojoule per mole. First of all, we have to add these two, and from this value you have to subtract this. You will get minus 84.4 kilojoule as enthalpy of formation. Now next problem we have to discuss about. Fifth problem. What is fifth problem? Calculate standard enthalpy. Calculate standard enthalpy of combustion of ethanol from the following data. Again here three thermochemical equations or two equations are given. First, C2H4 gas plus H2O liquid. It gives C2H5 OH liquid. And enthalpy change of this reaction delta H1 is minus 42 kilojoule. Second equation is given C2H4 gas plus 3O2 gas, it gives 2CO2 gas plus 2H2O liquid, and the enthalpy change of this reaction delta H1 is minus 1410 kilojoule. From this data you have to calculate the enthalpy of combustion of ethanol. Now required equation, how this problem is solved. Required combustion equation. Now the substance to be combusted, its 1 mole is written on product side and it is treated with excess of oxygen. That means here 1 mole of ethanol in liquid state is combusted with air, means oxygen. On combustion it forms carbon dioxide gas plus H2O liquid. This is rough equation. Now in ethanol molecule 2 carbon atoms are there. You write 2, 5 plus 1 6 hydrogen atoms means 3 H2O molecules. Now products are balanced. Now oxygen is to be balanced from product to reactant side. 2 into 2 4, 4 plus 3 7. Out of 7, 1 is already balanced with 1 oxygen atom. What are left? 6 atoms are there left. On reactant side means 3 O2 molecules. This is required combustion equation for ethanol. Now this equation is to be obtained from the given equation. Now what modifications are done? By checking every space in the given combustion equation, you can modify these equations we want. Here in given equation 1 mole of ethanol is given, but it is on product side. it must be on reactant side. Therefore, we have to reverse equation 1. Second, here we want C2H4. Now you can keep equation 2 as it is, because here we want 2 CO2 gas molecules on product side. Therefore, equation 2 is to be kept as it is. Keep equation 2 as it is. And third, add both the modified equations. Now, modified equations. First, we have to reverse equation 1. It becomes C2H5OH liquid to give C2H4 gas plus H2O liquid. If equation is reversed, its sign of the enthalpy is also to be reversed. From minus it becomes plus. Delta H naught becomes plus 42 kilojoule. We have to keep equation 2 as it is. That means equation 2 C2H4 gas plus 3O2 to give 2 CO2 gas plus 2H2O liquid, and enthalpy is also kept as it is. Delta H naught will be equal to minus 1410 kilojoule. By algebraic sum, if you add these two, C2H4 gas gets cancelled, and we get C2H5OH liquid plus 3O2 gas to give 2 CO2 gas plus 1 H2O plus 2 H2O, 3 H2O liquid. We get the required equation. And by algebraic sum of enthalpies of these modified equations, we get enthalpy of combustion of ethanol minus 1368 kilojoule per mole. This is the answer of this fifth problem. Now we have to see about next problem. Sixth problem. Calculate standard enthalpy. Calculate standard enthalpy of combustion of methane from the following data. Now here three equations are given. First, carbon graphite plus 2H2 gas to give CH4 gas. And enthalpy of this reaction delta H naught is minus 74.8 kilojoule. Second equation, carbon graphite plus O2 gas to give CO2 gas. And enthalpy of this reaction, delta H naught is minus 393.5 kilojoule. And finally, third equation, H2 gas plus 1 of O2 gas to give H2O liquid. And enthalpy of this reaction, delta H naught is minus 285.8 kilojoule. From this data, 85.8 to 85.8. From this data, we have to calculate enthalpy of combustion of methane. That means required combustion equation. Required combustion equation is what? 1 mole of methane in gaseous state is burned with oxygen to produce CO2 gas and H2O liquid. This is rough equation. Now in methane molecule 1 carbon, therefore we get 1 CO2 molecule. 4 hydrogen atoms, they give 2 H2O molecules. Products are balanced. Now oxygen is to be balanced from product to reactant side. O2 plus O2, 4 oxygen atoms, that means you can write 2 O2. This is simple combustion equation of methane, and the same equation is to be obtained by modifying these equations. Now what modifications are done? First, we want 1 mole of methane on reactant side, but in equation 1 it is present on product side, therefore reverse. Equation 1. This is the modification. Second, we want CO2 on product side. In second equation it is present on product side. Therefore keep equation 2 as it is. What about third equation? Multiply. Now here we want 3H2O, 2H2O, and therefore you have to multiply equation 3 by 2. Equation 3 by 2. That means we get 2H2 gas plus 2H2 gas plus 2 by 2 means 1. O2 gas to give 2H2O liquid. This is the equation. Now here equation, all these modifications are done. That means here you write multiply equation 3 by 2 and 4 add all the modified equations. Now modified equations. First, we have to reverse this equation. That means CH4 gas becomes reactant and carbon graphite plus 2H2. H2 gas. They become reactant. Equation is reversed, therefore enthalpy change becomes delta H naught plus 74.8 kilojoule. Second equation you have to keep as it is. That means carbon graphite plus O2 gas. O2 gas, it gives CO2 gas. Enthalpy change is same. That means minus 393.5 kilojoule. And third equation is to be multiplied by 2. That means it becomes 2H2 gas plus 2 into 1 by 2 is 1 plus O2 gas to give 2H2O liquid. Its enthalpy is also multiplied by 2. It becomes minus 571.6 kilojoule. All modifications are made. Finally, you have to add these modified equations. Here, carbon graphite cancels. H2, 2H2 gets cancelled. And what we get? CH4 gas plus here O2 plus O2, it becomes 2O2. And on product side, what is left? CO2 gas plus 2H2O liquid. CO2 gas plus 2H2O. We get required equation. And enthalpy of combustion of methane can be obtained by algebraic sum of these three terms. First of all, you add these. Value will be negative. And into that, you from this value subtract this. Bigger value will be negative. And here answer will be 890.3 kilojoule per mole. This is the answer. Enthalpy of combustion of methane. Now, next problem we have to discuss about. Seventh problem. Calculate standard enthalpy. Calculate standard enthalpy of the reaction. Reaction is given. It is given as 2Lp solid plus 3 by 2 O2 gas. It gives Fe2O3 solid. From the given data. Here two equations are given. First, 2Al solid plus Fe2O3 solid. It gives twice Fe solid plus Al2O3 solid. And enthalpy of this reaction is given minus 847.6 kilojoule. Second equation is given twice Al solid plus 3 by 2 O2 gas to give Al2O3 solid. And enthalpy of this reaction is minus 1670 kilojoule. Now here required equation is what? it is given twice Fe solid plus 3 by 2 O2 gas to give Fe2O3 solid, and we have to calculate standard enthalpy of this reaction. What modifications are done to get this equation? By seeing this equation, we can modify. Now, first modification. Reverse equation 1. Why it is to be reversed? Because we want 2 Fe solid on reactant side, but they are present on product side in the given equation. Therefore, this equation is to be reversed. Second, keep equation 2 as it is. Why it is to be kept as it is? Because we want 3 by 2 O2 on reactant side, and they are present as per our expectations in equation 2. And finally, add both the modified equations. These are only the modifications are to be made to get required equation. Now, modified equations. We have to reverse equation 1. On reversing, it becomes twice Fe solid plus Al2O3 solid. It gives what? Twice air solid plus Fe2O3 solid. Equation is reversed, therefore its enthalpy of reaction also gets reversed. From minus it becomes plus 847.6 kilojoule. Now we have to keep equation 2 as it is. That means 2 air solid plus 3 by 2 O2 gas. It gives Al2O3 solid. Equation is kept as it is, therefore its enthalpy remains same as it is. It is what? Minus 1670 kilojoule. Now we have to add these modified equations. Now 2 Al gets cancelled, Al2O3 gets cancelled. What is left? Twice Fe solid plus 3 by 2 O2 gas. It gives Fe2O3 solid as per our expectations. And enthalpy of this reaction, standard delta H naught, is obtained by adding these two. We get minus 822.4 kilojoule. This is enthalpy, standard enthalpy of this reaction. This is 7th problem. Now we have to discuss last problem in this respect. Eighth problem. What is eighth problem? Calculate delta H naught of the reaction at 25 degrees Celsius. Reaction is given SiO2 solid plus 3 carbon graphite to give SiC silicon carbide solid plus 2CO gas from the given data. Here only three equations are given. First, Si solid plus O2 gas to give SiO2 gas. Enthalpy of this reaction delta H1 is minus 911 kilojoules. Second equation, carbon 2 carbon graphite plus O2 gas to give 2CO gas, and enthalpy of this reaction delta H1 is minus 221 kilojoules. And last equation is given Si solid plus carbon graphite, it gives SiC silicon carbide solid, and enthalpy of this reaction is minus 65.3 kilojoules. Now this problem is to be solved. We want this equation by modifying these given three equations. Now required equation. What is required equation? SiO2 solid plus 3 carbon graphite to give SiC solid plus 2CO gas, and we have to calculate standard enthalpy of this reaction. What modifications are done to obtain this equation? First of all, we want SiO2 on reactant side, one more, but in equation 1 it is present on product side. Therefore, reverse equation 1. Second, here we want carbon on reactant side, 3 moles, but in equation 2 are present. Equation 2 is to be kept as it is. Keep equation 2 as it is. Third, one more carbon is present in equation 3 on reactant side as per expectations, and therefore keep equation 3 also as it is. And finally add all the equations, all the modified equations. Now modified equations. First, we have to reverse this equation. SiO2 gas, SiO2 solid. Here, SiO2 solid gives Si solid plus O2 gas. Equation is reversed, therefore enthalpy from minus it becomes plus. Delta H naught will be equal to plus 911 kilojoule. Third, we have to keep equation 2 as it is. It becomes 2 carbon graphite plus O2 gas to give 2CO gas. Enthalpy same. Delta H naught is equal to minus 211 kilojoule. And third, equation is also kept as it is. Si solid plus 1 carbon graphite it gives 1 mole of silicon carbide solid. Now enthalpy change delta H naught is minus 65.3 kilojoule. Modifications are made, and finally we have to add all these. Now here you can see silicon gets cancelled. Now here SiO2 solid plus 2 carbon plus 1 carbon, 3 carbon graphite. 3 carbon graphite. On product side, what is left? Here oxygen also gets cancelled. On product side, we get only SiC solid plus 2CO gas, and we have to calculate enthalpy, standard enthalpy of this reaction by algebraic sum of these three. It becomes plus 624.7 kilojoule. You have to add these two, and from this value you subtract addition of these two, we get plus value plus 624.7 kilojoule. This is the answer of 8th problem. In this way, in case of Hess law, we covered all the types of problems. Thank you.